Hey, what's up? Chin here from Code and Quick Tips. Today with a new video on a basic 2D jump and run game. In this video we wanna basically finish the code from the last tutorial video. If you haven't seen that, please have a look at that before you watch that, because you will need the base code to work and to improve that base code. So what we will do today is basically we want to add the ability to jump for our player, and we want to get rid of give a second, what we have discovered last time, which is this inaccurate movement. Basically we want to get the movements smoother in code, and that will prevent those errors. So to get started, the first thing, the easiest thing, is how to handle jumping in our game. To start off, we handle jumping like every other input, and we start by saying we want to trigger the action if our key is pressed. So let's start by doing that and say if gc.getInput.isKey down, and here we want to use I guess input.keyUp here. Let's use that as a jump key. Here we go. So now we will trigger set if statement every time we hit the up key or if the up key is down. But as you all know, a player can't just jump. A player can only jump if he got some solid floor under his feet, because otherwise you can't jump, quite obviously. And that's exactly what we're gonna use to get our jumping mechanics done. So how can we see if our player has basically solid ground under his feet? So that's quite simple. As we have written down here, our player will never actually hit the level in any ways. If it hits the level, or if it would hit the level, it will get reversed out of the level or moved out of the level. So basically we will never actually hit the level. We will always hover a little tiny bit above the ground. And we can use that for our advantage. We can say, well, if we hover a little bit above the ground, then we will do the following. We will move our player a little tiny bit down, and if we do that and we hit then the ground, then we know we were before just a tiny little bit above the ground. So basically we were at the ground. We can use this because 0.1 is basically that small that our player won't recognize if he can't jump while he's still hovering above the ground. So it's basically, technically our player is able to jump before he hits the ground, but out of a player's perspective, you won't notice that. And we use that. So basically we say our player is hovering above the ground if we want him to jump. And if he's hovering just a tiny little bit above it, we move him down, and then we can get the collision. So here we say we move the player down a tiny little bit. And we do that. And after we done that, we say, well, if we moved our player down a tiny little bit and it collides with the floor, it was just right above the floor, and therefore our player was able to jump. And if our player is able to jump, then we only have to do one thing. We want to reset the Y speed, because at the point where you jump, we want to have a rapid speed of our player. We don't want to accelerate him, so we just set the speed, the Y speed, and we basically set it to our jump strength, so we can adjust how high he will jump. So what we do here is we check whether our player is able to jump with that simple statement. And if our player is able to jump, we just set the Y speed to a level that is okay for us and that is okay for our jump height. Because with that Y speed, he will basically fly up, and this Y speed will then be affected by gravity again. And therefore our player will get lower and slower with the upwards movement, and we get that nice movement curve that you're used. And it's actually an accurate movement curve. If you look at that, you can go in mass and calculate that, it will work always the same. And after we have done the jump test thingy, we obviously want to do the same thing. We want to redo our movement down, because if there was no floor beneath us, our player would basically float up if we hit the jump key. And with that we just undo that movement, because this movement here was just to make this check work. And so we undo the movement from here down here. So if we cannot jump, the jump key will basically do nothing. It will just test fails, reverse movement, and nothing happens. So if we can give that a quick try, you can see, oh, why can't it jump? Oh, that's sad. Let me have a look at our code. If input is key down, key up, let me test that. If I need a bigger value here, that won't work. Maybe more jump strength. It's always good to have more. Actually, I'm a bit surprised here. Give me a second. So if something won't work, just go and do some debug lines. That's the best thing you can do. So let me put that here. So if we actually start the jump action, I will write out jump, and it's not printing. Give me a second. I'm gonna search for the error. We move the player down, and well, I'm not sure. Let me get that out here and test it now. Okay, it recognizes the key press, but it won't recognize the jump itself. So let me have a look at that. We move the player down a little on the y-axis, and then we save our level collider. We could increase that, but I don't think that will help in any way. Oh, it helps. Apparently, what happened here was, because our movement wasn't smooth, we had the same effect as here, just at the bottom, down here, and our player was always floating a little above the ground, and therefore we couldn't reach the critical point where our player was near enough to the ground to actually jump. That problem would have been fixed with what we will do just in a second, but it's not bad to have it that way. So what you can see here is, if I press the up key and hold it, we can only jump if we actually hit the floor. And now we can actually get up on this little platform, which is quite nice. If it seems laggy, that's the recording. And here you can see why we made the player a little smaller than 50, because then we fit through gaps, which is quite nice. So, wow, here we go. We basically have created our very, very simple movement. What you will see here, here's the same. I can't go to the left here, but I should be able. I don't know. So, you see our movement is a little clunky and not really precise. So, what physics engines actually do to make this movement better and also input better is either input iteration and position iteration and also velocity iteration. What that means basically is you calculate the position or the velocity more often than you render your scene. So basically per frame you would calculate your physics in 5 little steps. So you will see what that means in a second. I'll just show that to you. One basic thing you need for that is you need a value that describes how precise is your physics simulation or your position simulation. Sorry for that. Basically this means then higher your position is, then higher the CPU load will be. And you need to see whether you put this in a setting or something like that. So what I will do here is I will add a static float or run float, an integer, for the number of iterations we want to do to our position. In our case we will just do position iteration, as that will be enough. So what we will do here is we will basically say we will move the player, instead of 1 step a frame, we will move him in 5 small steps, and therefore our movement will get more precise. So what we can do here is we can say we'll do the movement and all set for a specific number of times. So int I equals 0, just a simple for loop, set as small as an iteration. So we will basically go over the player's position for the number of iterations we have set in our settings. And that way we will have more precise movement. Now it wouldn't change anything, because we actually need to split up our movement into smaller movement steps. So what I will say here is float y velocity y temp or something, which will be the velocity we'll use here. So give a second. Here we go. We won't move our player with our full velocity each iteration. We will just move it with a part of our velocity. So in my case, I said iterations equals 5. So I would move the player with a fifth of his speed 5 times after another. With that, what we will get is basically we will have 5 times more precise movement because we do our usually one movement step in 5 small steps. All I have to do here is to exchange that here. And here we go. What that should do is... Oh, actually, it doesn't. Give me a second. Our player hovers over here, and that's what makes me think what's happening here. Give me a second. If I change that to 1, it basically does what we have done before, and it does exactly the same. So, oh yeah, screw me. Do not change that because here we reset the actual velocity. I'm really sorry for that mistake. So, what we do now here is we say we take our initial velocity, part it into takes a fifth part of it, and then we go over our movement and collision algorithm just 5 times in 5 small steps. And if we go here, that will be more precise in theory, but you won't see much of that. But it works, it's more precise. And what you can see here, I could jump upwards and then go through that hole before, but I can't do that now as it's more precise now. So I want to do the exact same thing for our X movement, and here you will see like a really big impact. So let me copy that over down here. We want to have it for our X movement. Change that. So here we go. I just applied the exact same code on the X movement, and you know the bug we had here on the left before with that little space we had because we would move too far at one frame. We don't have that now, at least you can't see it, because now we do 5 small movements instead of 1 big, and therefore we can get 5 times closer to the wall without triggering the collision code and not letting us go closer to the wall. So basically what we did, instead of doing 1 frame movement here, that would have stuck us at that position, we can go 5 times more precise down here. One thing to notice is, well, why don't just do the iterations unbelievable high, and then I will have a perfect game? Yeah, sure, you can try that, and it will make your game smoother, for sure. But I don't know if you, first of all, will see a big impact at a specific point. So I would say at about 10 you won't see a big impact if you just go higher. So that's the first thing. And the second thing is, does your player really want to have 5 times higher CPU load for 0.5% more precise gameplay that you won't even notice? To be honest, I don't think so. So be careful with that, but I think 5 to 10 is a good value for that. With all that, we have a really basic 2D game. We can jump around, we can run around, we can collide with the world, you can add enemies to it, you can jump down, you can jump through that. And if you really want to, I can do a video on things like power-ups and enemies, how you could place them in here. And you can either use that technique and just combine it with our regular tile map, so you basically map per hand around those tiles. But I think, I'm not sure yet, but I might write a small helper class for you, so sorry, so you can easily import tile maps and apply collisions to that. But I will see how I will handle that. Sorry, sorry for that. With that said, I think we have wrapped up the real basics of 2D movement and a 2D jump and run. You can apply the exact same thing as I said earlier to a top-down game by just not activating the gravity and applying the same movement as the X movement to the Y movement, and then you have a basic top-down game. With that said, I really hope you enjoyed, and you will find also that code on GitHub. If you enjoyed the video, please feel free to leave a like, that helps me a lot. If you haven't enjoyed the video, let me know why you haven't enjoyed the video in the comments. If you have any constructive feedback, or if you have any wishes for further tutorials or any other questions, leave me a comment. And if you enjoy all my videos, then consider subscribing, as that helps me a lot too. With all that said, I really hope you enjoyed, and I will see you next time.